So we're going to start learning how to graph lines by putting into slope-intercept form. Slope-intercept form is a form that you guys have been doing without really knowing it. First, to get it in slope-intercept form, we solve for y. We get the y by itself. And then second, we make sure that the equation looks like y is equal to something, which we call m times x, plus another something, y equals mx plus b. An example of this would be if I have a line that looks like this: x over 2 plus y over 4 is equal to 6. Then if I want to get that in slope-intercept form, I could do what we did before, where I multiply both sides by a least common denominator of 4, get rid of that problem. So I'm going to multiply each of these by 4, and I get 2x plus y is equal to 24, and then I subtract 2x from both sides, and I get y is equal to negative 2x plus 24. And that is slope-intercept form because that matches y equals something times x plus another something. So given that, I know that when I look at this line, I can say that the slope is equal to the coefficient of x, which means that the coefficient of x is this negative 2. The slope is negative 2, and I use the lowercase letter m to indicate that. I also know that the y-intercept is equal to 0, comma b, whatever this b is. This right here is a positive 24, so in this case it is 0, 24. And that tells me what the y-intercept is, and there's the slope. So some examples that you might see are to find the slope and the y-intercept. So first example would be y is equal to negative x over 2 plus 5. Well, we don't have to manipulate this one. I just need to look at the slope equals the coefficient of negative x over 2. And this would be, remember there's an invisible 1 right here, so that's equal to negative 1/2. And then the y-intercept is equal to the ordered pair 0, comma 5. This should make sense because if I plug 0 into the function, if I plug 0 in, I get y is equal to 0 plus 5, or 5. So 0, 5 is an ordered pair, and there's the slope and the y-intercept. Some other examples would be things like number 2. If I have y is equal to, let's do 10 minus 3x. That's not in slope-intercept form, so I want to switch the order of the 10 and the negative 3x. I'm going to make that negative 3x plus 10. And then now I can look and say my slope is equal to negative 3, and my y-intercept is equal to 0, 10. And then I plug that in there, and I'm good. So there's slope, and there's y-intercept. So next equation would be something like y is equal to negative 2. And if I'm talking about y equals negative 2, this really doesn't look too much like y equals mx plus b. I don't have an x. And I don't really have a very good idea. So let's start with the y-intercept. If I look at the y-intercept, if x equals negative 2, if x equals negative 2, then y is definitely going to be negative 2. If x equals 0, y equals negative 2. If x equals 5, y equals negative 2. This right here is the y-intercept because x equals 0, y equals negative 2. But you should see that y is negative 2 no matter what. So I could say that the intercept is y is 0, negative 2. But now if I talk about slope, this is a little bit tricky. You guys should know from earlier that y equals are horizontal lines. So the slope of a horizontal line is always 0. So I know that slope is equal to 0. Again, we're looking at a y equals, I know it's a horizontal line, so then I know that it has a slope of 0. Let's look at x equals negative 10. X equals negative 10. So if I want to find a y-intercept, I know I have to say what happens when x equals 0. Well, if x equals 0, we have a problem because this says x equals negative 10. This means that there is no y-intercept. There's no y-intercept because x cannot be equal to 0, because this equation actually says x is negative 10. This should make sense because if you learned from before that x equals negative 10 is a vertical line. And if I sketch this, it's going to be a vertical line right here. Let's draw that in a different color. It's going to be a vertical line somewhere out at negative 10, and it's not going to cross the y-axis ever. It's going to run parallel to the y-axis. And the slope of all vertical lines is undefined. I can't calculate a slope of that, and we'll get to why here in a minute, but this is an important idea to remember. So we have two ideas here. One of them is that if you have a y equals equation, I'm going to zoom in on this and kind of expand this up a bit. If you have a y equals equation, then the slope is equal to 0 and the line is horizontal. If you have an x equals equation, and I'm going to modify this with no y, and this is an y equals equation with no x. But if you have an x equals equation, then the slope is undefined and the line is vertical. I can't think of two probably more important facts to remember in this chapter than those two, or to reason through. And I like reasoning through. This is why these next couple examples are going to show us this, because we can always figure this out. So next direction set is just to calculate the slope. This is kind of a little bit of review from the day before. So if I calculate the slope of, let's see, this is number 5. Let's calculate the slope of 7, 1 and 7, negative 2. So I know from before that slope is equal to the change in y, 1 minus negative 2, over the change in x. And I get 3 over 0. Right there, that's a red flag. We have 0 in the denominator. You can't divide by 0, so we say that this is undefined. Let's take negative 1/2 7 and 6 7. And if I calculate a slope on that, I get 7 minus 7 over negative 1/2 minus 6. And I get 0 over something. Now, negative 1/2 minus 6 is the same as negative 1/2 minus 12 halves or negative 13 halves. But that doesn't matter as much because 0 divided by any non-zero number is equal to 0. And we can say slope is 0. And that's perfectly fine. We can also now give you some fractions in these. If I say the order pair 1/5, negative 2/3, comma, 3/5. Actually, let's do 4/3. No, let's keep it at 3/5. 3/5, negative 1/3. And I want to calculate a slope of those two. I still have to set up my change in y over change in x. So I'm going to do it kind of like I did before, where I do parentheses minus parentheses over parentheses minus parentheses, and just kind of fill these in. Negative 2/3, 1/5, negative 1/3, and 3/5. And I'm going to simplify this over here. This is negative 2/3 plus 1/3 and 1/5 minus 3/5. Add the numerator up. This is negative 1/3. Denominator, this is negative 2/5. I know that they're both negative, so I can make them both positive. but I still want to come up with a strategy to get rid of the fraction within a fraction. Well, if those were proportion, or, sorry, if that was a ratio, I could just multiply the top and the bottom both by 15, and I'm going to get 5 over, and when I multiply the bottom, I mean I'm multiplying the fraction by 15, so this is really kind of like a 15 over 1 times both. So this gives me 5, and this gives me 6, and I get 5/6. Okay. Next step is to graph using slope and y-intercept. So we've graphed by doing x and y-intercepts. So we've graphed by t-chart, and this is a new kind here. So for my example, I'm going to go y is equal to negative 2/3 x minus 4. Well, before I graph, I'm going to look at this and say that I know that the slope is equal to negative 2/3, and the y-intercept is the point 0, negative 4. So knowing that, I'm going to put a grid down, and I'm going to put the ordered pair 0, negative 4 down. From there, I'm going to do a slope of negative 2/3. Remember, that means down to right 3, or that means up to left 3. So down to right 3 is here, up to left 3 is here. Whenever you graph these, I want you to graph as many points as you can, so we can keep going down over or up over and put all these points down through the entire length of the graph. And then finally I'm going to put a line down and connect all those. Number 9. If I have y is equal to negative 5/4 x plus 2, looking at that, I'm going to have a slope of negative 5 over 4 and a y-intercept of the ordered pair 0, 2. So put an axis down, plot the point 0, 2, put it right here. Slope of negative 5/4 means down 5, right 4, or up 5, left 4. You can even, instead of going down 5, right 4, go down 2.5, right 2. That's half of what we just did, and that puts 2 more points down, which makes this a lot easier to draw, especially making sure that your straight edges connect all the possible points that this goes through. So I just put as many points down as I can, and then this line tool I use needs points to connect. That's why I make sure I hit the very ends. But you guys, no dinky graphs. I don't want you guys doing stuff like this. You've got to fill the entire space, which means you need to be putting as many points down as you have space to. Sometimes these equations we use are not in slope-intercept form. Maybe I have something like 3x minus y is equal to 2. Let's make it equal to 6. Okay, so 3x minus y equals 6. If I subtract 3x from both sides, then I get negative y is equal to negative 3x plus 6. Multiply both sides by negative 1, and I get y is equal to positive 3x minus 6. Then I can go ahead and say that my slope is 3, which for a slope is the same as 3 over 1. And the y-intercept is the ordered pair 0, 6. So I'm going to plot 0, 6. Then I'm going to go up 3, right 1, or down 3, left 1 as many times as I can. Down 3, left 1, down 3, left 1. And then once I hit some very edges, I'll put the line down. I'm going to need to zoom out to do that. Okay, so that's what you're going to have a lot of practice doing. I'm going to give you one more example, because sometimes people get a little confused if the y-intercept is a specific number. If I say 4x equals 5y, we still want to solve for y, so I'm going to divide both sides by 5, and I would get y is equal to 4/5 x. My slope is 4/5. My y-intercept is 0, 0, 0. So that's the origin. So my first point I'm going to put down is the origin, and then I'm just going to go up 4, right 5, up 4, right 5, or down 4, left 5, and then down 4 and left 5. And then make sure that I connect to all the possible points. Oops, I did that too fast. And that's it.